In this application, we're going to be looking at this medical sample, and we're going to be using the CL2 MG210 probe. And this is one of our white light confocal probes. And to give you a quick example, here's the setup, here's the controller. This is how the probe works. It creates a monochromatic image, and we're going to be measuring the change in the color coming back. It's a completely passive probe, and we have different sizes and different measurement spans. We chose the CL2, which has a 0.4 millimeter measuring range and 11 millimeter standoff. We're going to have a resolution of 22 nanometers, and will be accurate to plus or minus 80 nanometers. Very accurate. We use the MG210 magnifier, which creates approximately a spot that's about 2.5 microns in diameter. So very, very small spot. It can measure easily plus or minus 28 degrees. So this is the probe that we used. And what we noticed when we scanned this, of course, we're on an XY stage. So with a radial part like this, we did have some dropouts on some of the features you can see right around here on some of the real sharp slopes. And we basically just took a small area here, about a 1.5, I think we took approximately about a 0.75 millimeter by 0.75 millimeter scan over the target here, and we took a data point every 1.5 microns. So we have collected this very large cloud of points, and this is what that 2D profile looks like, color graduated. And as you can see, as we talked about, here's some of these dark areas are some of the dropouts where the slope was too steep. But here you can see that we are definitely getting that target surface very well. I mean, very good measurements on that surface. And if we look at that in 3D, you can kind of get a much better sense of the profile of this part. And like I say, once again, on some of those real steep joints, we lost it. But typically what we'd recommend on something like this would be to use the probe not in an XY configuration, but have the target on a rotary stage or rotary table. And as you would rotate that spot would go across it, and then you would move the probe up. So you'd collect a 360 degree radial surface, which would be, would take away a lot of these dropouts. Let's go ahead and just take a quick look at what that profile is going to look like. We'll give you sort of a flying view of as we're measuring across these, and as you can see, here's those surfaces. But even with the dropouts, you could put in a smoothing filter to show those very accurately. And as you can see here with the little stage, we're looking at 40-50 micron sort of depth. In the west and east, we go north to south. It's showing exactly what that surface looks like across there. And of course, as we get into some of the areas, you can see that we're starting to pick up the radial surfaces. But even with those dropouts, we should be able to do a very good job.